Hello, my name is Ritika Danny from West Lafayette Junior Senior High School, and today I'll be talking about segregation of micro and macroplastics from wastewater using electrolysis. The purpose of this experiment was to find an effective way to remove micro and macroplastics from wastewater because it's been seen across our food chain. If we could take benefits of positive and negative charges on the plastics using electrolysis to separate different types of plastics. My hypothesis was that if positive charged plastics got attracted by the cathode of my electrolysis, we could easily filter out the plastics from wastewater. My experiment started off by gathering the three most commonly used plastics, which is polystyrene, which I used red solo cups to implicate, polypropylene, which is drinking straws, and polyethylene, which I used plastic bags. I measured 100 grams of plastics, which was mixed into a brine solution that consisted of 3 liters of water with 150 grams of salt in a glass container. I used two different anodes, which consisted of a graphite rod and an iron rod. For my cathode, it was made up of a metal mesh in order to trap some plastics that got into it. I used a DC power supply, which I applied 5 volts and 12 volts to the electrolysis solution. The drift of the plastic to 50% and 75% of the electrolytic bath was measured using a ruler. This page of results shows when a graphite rod was used. As seen here, the polystyrene and polypropylene plastics drift towards the cathode at a much faster rate when 12 volts is applied compared to the 5 volts. Electrolysis did not show any impact on the drift to polyethylene. This slide also shows the experiment when performed using an iron anode. As compared to the previous slide, we see both polystyrene and polypropylene moved to the cathode when at a faster rate, and the electrolysis has no impact on the polyethylene. In order to derive confidence in my experiment's results, I calculated the p-value for polystyrene and polypropylene in 5 volts and 12 volts. The calculated p-value shows me that there's a higher correlation between the results of the two plastic groups. In summary, plastics such as red solo cups and drinking straws have been used for food and consumption and can natively has a positive charge since that prevents bacterial growth. I've observed that polystyrene and polypropylene have particles that are attracted towards the cathode, thereby my hypothesis has been proven correct. For future research, I would like to try different plastic groups that would demonstrate something similar to my test. Additionally, electrolysis was performed in a brine solution, but I would like to try it in different solutions such as wastewater to see if my results are duplicable. As part of electrolysis, my anode has had a tendency to degrade over time, and I would like to find an anode that's more durable and can give me the best results. My experiment was performed in a home lab, and I would like to use materials such as a spectrophotometer to analyze my electrolytic solution before and after to see if there are any changes in the composition. Here are my references, and thank you.